In modern assembly pipelines, identifying anomalies is crucial in ensuring product quality and operational efficiency. Conventional single-modality methods fail to capture the intricate relationships required for precise anomaly prediction in complex predictive environments with abundant data and multiple modalities. This paper proposes a neurosymbolic AI and fusion-based approach for multimodal anomaly prediction in assembly pipelines. We introduce a time series and image-based fusion mechanism that leverages decision-level fusion techniques. Our research builds upon three primary novel approaches in multimodal learning: time series and image-based decision-level fusion modeling, transfer learning for fusion, and knowledge-infused learning that utilizes the process ontology that we design and develop. We deploy the NSF-MAP and process ontology at the Future Factories testbed at the McNair Center, University of South Carolina. Now, let's examine the NSF-MAP interface and how it is utilized for anomaly prediction. The prediction dashboard of the NSF-MAP user interface begins analyzing when the assembly process starts and the Start Analyze button is pressed. If the assembly hasn't started, no values will appear in the table. Once the assembly begins, the graph displays the corresponding sensor values, and the cycle state box will show the next cycle state. The prediction text box shows the predicted anomaly. After the anomalies are predicted, you can get user-level explanations for each of the anomaly predicted in the assembly cycle. Experience the next generation of manufacturing intelligence.